Okay. All right, so here we go. Number one. Everybody got one? All right, here we go. Let's look at these numbers. Now, we don't have a calculator. So we're not just going to be typing all this in. And, oh, by the way, 2 to the 19th is huge.
It's a big number.
So let's look at 4, 16, and 2. They are not random numbers. What can you tell me about 4 and 16? They're more than that. They're not only divisible by 2, they're all powers of 2. Right? So here's what I mean. 4 cubed is 2 squared cubed. 4 is 2 squared, right? And it's being cubed. So that is 2 to the 6th. So 4 cubed is the same as 2 to the 6th. Now what about 16 cubed? What's that? That's 2 to the 4th. To the 3rd. So that's 2 to the 12th. 16.
You put 12.
Huh?
You put 12.
Oh, all right, 2 to 12. Okay. And then what? And then 2 to the 19 is 2 to the 19.
Yeah.
All right. So what have I got on top? On top, I've got 2 to the 6th times 2 to the 12th. And on the bottom, I have 2 to the 19. See how simple this is going to be, you guys? What do I do with these?
One stays the same.
Well, 2 stays the same. Exponents get added.
Yeah.
So that's 2 to the 18th over 2 to the 19th. So 1 over 2 is the answer. 1 over 2. So what was the key to doing that problem? Recognizing that all of the bases are the same. I can change them all into 2's.
Didn't we do stuff in algebra too a little?
Yeah.
We all know this stuff.
Okay.
Yeah, how'd you get 1 over 2 again? I'm sorry.
What's 18 twos divided by 19 twos? We're going to cancel. And you're going to have 1 extra one in the bottom.
Oh, okay.
Right?
Yeah.
Come on. Engage.
So if it was 18.
It's been a long day.
Let's go.
All right. 7/8 to the -2nd.
Flip the fraction over.
Flip the fraction. Whenever you have a negative exponent, you're going to flip the fraction. So that's going to be 8/7 squared. We never mess around with the exponent. It just becomes +2. And then we just square everything. So 64 over 49. That's the answer. 25/36, x to the 8, to the -1/2. Well, again, you have a negative. So we're going to flip the whole thing. And then it's going to be to the 1/2. Now remember, what does a 1/2 exponent mean? Square root. So I'm taking the square root of 36x to the 8 over 25. So that's going to be 6 x to the 4th over 5. And that is your final answer. If you are all confused, sometimes it gets confusing when I write it as a radical. Remember, what's happening with these 2 exponents? They are being multiplied. So that's where the 4 came from. 8 times a half. Okay. Number 4.
You don't need to flip fraction.
Now this one looks confusing. So let's make sure we're just looking at it one piece at a time. You cannot flip the whole fraction. Does everybody understand that? Because the whole thing is not to a negative power, pieces of it are to a negative power. So, my own personal preference, I'm gonna leave that 5 right there. And this guy, I'm gonna bring it down to the bottom. Just that. Now, this parentheses is gonna go to the top. Oops. So that parentheses is gonna go up to the top. So this guy is coming down. This parentheses is going up. And now I can simplify. So what have I got on the top? 5 times, okay, 5 cubed is 125. X cubed over x cubed. So it looks like the answer is 125 times 5, which is 625. That one's confusing because you only move part of it. Number 5 is the same kind of thing. It looks a lot easier, but it's the same thing. What's that gonna be?
8 over x.
Yes, indeed, very, very good. 8 over x squared. The 8 stays, the x squared comes down. Beautiful.
Is that it?
That's it.
Yeah, you
How about 6?
X over 3.
You're gonna flip it and make x over 3, and then you're gonna square it.
X squared over 9.
X squared over 9. Beautiful, beautiful, beautiful. Now, number 7 looks a lot like number 1. Would you agree?
Definitely does.
I don't have a calculator, so dealing with things like 27 to the 9th, out of the question. I can't do that. So what am I gonna do with a 3, a 9, and a 27? Change them all into threes. So 3 to the 7th is 3 to the 7th. 9 to the 10th
3 to the 20th.
will be 3 squared to the 10th,
3 to the 20th.
which is 3 to the 20th.
Yeah. And then 3 to the 1st.
And 27 to the 9th is 3 cubed to the 9th, which is 3 to the 27th. So I have 3 to the 7th times 3 to the 20th over 3 to the 27th. That's 1, exactly. So that big ugly mess just came out to be 1. Keller, are you tired too?
I have a question about 6, so you can't simplify it anymore down.
What do you wanna do?
Oh, okay. Since it's a fraction, you can't make it x over 3.
It's not being square rooted. So no, I can't just, those numbers aren't divisible by the same thing, so that doesn't reduce. Alright, and then, boy, what about this last one? Again, there has to be something I can do here because I cannot do that arithmetic. That's crazy. What do I know about 24?
This is one of that too.
It's 3 times 8. So what if I change that 24 into 3 times 8? And now, these are being multiplied. So it's like having xy to the 4th. When you have x times y to the 4th, don't you take each of them to the 4th?
Yeah.
So this is gonna be 8 to the 5th over 3 to the 4th times 8 to the 4th. What happens right here?
Cancel.
They're gonna cancel and leave me with an 8 on top. So I'm gonna have an 8 on the top and a 3 to the 4th on the bottom, because that canceled. And 3 to the 4th, 3 times 3 times 3 times 3. 81, 9 times 9, 81. So the answer is 8 over 81. So tomorrow, or Wednesday, we'll have a quiz like this. That's all that's on it. It's just some exponent problems, and you're gonna simplify them. It probably won't even be 8, it'll probably be like 5 or 6. Okay? So, if you feel like you need to practice again, you can write those down on a piece of paper and practice them again. But now what I want you to do is put that away, because we are not ready for that for a while. Go to somebody else's class. Don't always come to mine and have to go on. All right. We are in our notes, getting ready to finish up 3-2. So this is a big week for us. Wednesday we have a quiz. 3-2 homework will be due on Wednesday, and your paper's due on Friday, right? So things are rolling on. All right, so we're on page 34 of our notes. We're ready for number 6, the spread of the flu. So we have an equation given to us. You have to help me out because, yeah, I think that's right. All right, there's my equation. And what does it tell me? It tells me the number of kids who have the flu after T days. So, what was the initial number of infected students? Now, be careful before you say anything, remember, the initial value is the value of y when x equals 0. So you can't look at this equation and answer it. You gotta put a 0 in there. Big 0 is going to be your initial value. If I put a 0 in there, isn't my exponent 0? And what's even a 0? 1. So what's my denominator? 1 plus 49, 50. So it looks like the initial number of people sick was 16. 80 divided by 5, is that right? 800 divided by 50, 16?
Yeah.
Okay, so make a note in case you think you're gonna slip up on that. How do you find the initial number? You let x be 0. Now, in an exponential equation, you know, if you have something like this, then that's always going to be the initial value. But that's in an exponential. This is a logistic function. Let x be 0.
We will get our calculators for this.
You will need a calculator for these.
Yeah.
Not for the exponent quiz, for this, yeah. When will the number of infected students be 200? All right, now let's think about that. Plug in 200 weight.
No.
T.
I don't know.
What does T represent? Yeah, I don't think that's where I
For
want
what?
to put the 200. If I put a 200 there, that would tell me how many people were sick after 200 days. That isn't the question.
For why?
It's gotta go here, right? It's gotta go here. So, you have a choice. Probably what you're gonna need a calculator either way. At this point, probably what we wanna do I've got this equation, and I wanna know when it equals 200, right? So how about if I put that in as one equation, and 200 as the other equation, and then look where they cross each other? Otherwise, I'm gonna need logarithms to solve it. So, we'll put that in. Now, when you type that in, just make sure whatever you type in is exactly what you meant to type in. So y equals 800
What window should we use?
Well, we'll talk about that in a minute. And then your other equation is a 200.
Yeah.
Okay, so. Remember to get E in second ln. That whole thing is your exponent. So the window I used, and I got a good picture, my x's were 0 to 20, and my y's were 16 to 250. Now, and that gave me a fine picture, but so did other windows will work too. There was nothing magical about this. But here was my thought process. What does my X stand for? Number of hours. Wasn't it hours or was it days? Days, number of days. Okay, regardless, it has to be positive, right? So it makes sense. I just took a guess at this. I thought, well, it's gonna take a while, but not too long, so I picked 20 and got lucky. It could have been 30, it could have been 50, I don't know, I just got lucky on that one. Why for Y min did I put 16? Because I'd already figured out that was my initial value. I'm starting at 16 and going up from there. Why did I put 250? Because I had to be bigger than 200, right? That was my other equation. So to see that line at 200, I have to be more than that. All right, did you find your point of intersection yet? I have not. I got T equal to 13.966 days. Did anyone else get that? Now I'm gonna say something here, guys. I had a lot of whining and complaining, mainly from him, who's not here today, but about the calculator part of the last test. And part of the issue is, when I'm up here typing away, you're sitting there. You need to be doing it with me. So that when I say, who else got 13.966? There's a whole bunch of people that say that. Because you practice. The school will close when 300 kids are sick. When will the school close? Well, aren't we gonna do exactly what we just did, only we want this to be 300? Did you already do it, Elijah?
No, I was just.
So I'm gonna change that to 300. I'm gonna have to change my window. I had to make some adjustments to my window, obviously. 16.905 days, so about 17 days, we're gonna have to close the school. On day 17.
Cathedral's gonna be gone?
I'm kidding.
Oh, sorry, yeah, no,
Yeah.
you don't do that.
It's like,
All right. Number 7, we're just practicing another problem. Here we go, we have an equation. This is the number of deer. All right. How do we find out the initial population?
Plug in
Zero.
Plug in 0, all right? Go ahead and plug in 0. All right? Well, so that whole denominator has to be parentheses. We can't, you're not. So if you're having trouble, remember the denominator has to be in parentheses unless your calculator builds a fraction for you. Otherwise, if you're gonna type it in sideways, it's gotta be in parentheses. All right, so what was your initial value?
11.
Yep, 11 deer, perfect. When will the number of the deer be 600?
Plug in 600 to Y.
So this will be one equation, and then 600 will be the other equation.
Where does a 1001 go? Oh, you mean like the whole fractions one equation? Or
This
just
is
the bottom?
one equation.
Oh, okay.
Is there any window adjustments again? Somebody volunteer, when is the how many days or years, whatever it is?
24.514.
Yeah, years. So 24.514 years, beautifully done, beautifully done. What is the maximum number of deer possible in the park? This is what we talked about last time. This is a logistic function. Asymptote up here, asymptote here, looks like this, right? Now, this is the maximum, the top asymptote is your maximum population, also called the limit to growth. What is it? Exactly. Because this right here is gonna be one of your asymptotes. We talked about that last time.
So instead of a 1, it shows a 2 there.
It'd be 1001 over 2. All right, number 8. Last, we have a couple more. The population of Smallville in the year 1890 is this. Increased at a rate, estimate the population in 1915 and 1940. Okay, so we're gonna write our own equation. No equation given, we need to write our own. Exponential growth. This is what the equation's going to look like. A very much easier type of equation, exponential. So tell me what my A is. In this problem, what's my A? 6,250. That is my starting population. At least starting for the problem, that's the population. It's increasing 2.75% a year. Tell me what goes in here.
0.2, or 1 plus 2.
1.0275. What happens if you leave the 1 off? It doesn't grow, it shrinks, right?
Wait, is this like the same equation as doing like the 1 plus and 1 minus?
Yes.
Alright.
Okay, now there is my equation. I'm gonna use it to answer the questions. So what was the population in 1915? Well, 6250 times 1.0275 to what power? 25. And why are we taking it to the 25th?
25 years.
Because we're going from 1890 to 1915.
It's 1915 to 1940.
No,
90.
this is 1890. So it says estimate the population
Next one
in
we'll put
1915.
Next one we're gonna put 50.
It's a two-part question. So this is the population in 1915.
Yeah.
Then what would be the population in the other year? Well, you're still starting, guys. If you're using 6250, then you're starting at 1890.
Yeah.
So we're going from 1890 to 1940, so that would be 50.
Or you could plug in the answer to the first of 1950 and then do 25.
That's exactly right. Sam says you could start over and use this answer instead of this, and then make that just the 25th, because you'd be going from 1915 to 1940. All right, and how we doing 8B?
You just put 50.
Right, so one equation would be this one right here, and then the other equation would be 50,000. Let's go ahead and do that because I want to make sure you can interpret your answer. So 625. Adjust your window. This is what I got for my point of intersection. 76.651, comma, 50,000. Did anyone else get that? Jack, why are you not typing this in my
I did plug in the first one I got.
We're setting this equal to 50,000. That's right, anybody else get that?
What did you do for them? Yeah, some of them are like, what would you use? What window to use?
I just use my head. So
What number
I
is
know
it?
X and Y have to both be positive.
Yeah.
So my mins are gonna be 0. My X max, I just picked a number, and the first pick I wasn't big enough, so I picked a bigger number, ended up with 100 for X max. And then Y max I was 60,000, because I had to be bigger than 50,000. Did anybody get 76.651?
Yes.
Perfect. Now, we have to answer the question. Predict when the population reached 50,000. What, don't say 76, that is not the answer. What does that represent?
76 years from 1890.
Exactly. So it's 76 years, or almost 77 years
1960.
after, 1890? So it happened sometime in the year what?
1966.
1966? In the middle of 1966?
Would you be okay with that putting 1966?
Yeah. Yeah. Okay, 9 is almost exactly what we just did. So I want you and your partner to work at number 9. Figure out what your equation is, figure out what the graph is gonna look like, figure out your own window. Just figure it out. And I'm gonna take attendance, because I will do that. So no Jim Gardner.
Jack, do you think?
No Tyler. No Jalen.
Yeah.
No Dana. Yeah. Where are all these people?
Skipping.
That's a lot to be gone.
They're gonna wanna help for tests and stuff.
I put 8. Oh wait. Is 1 million 8 zeros?
Windows have to be like short.
But our
I'm gonna go
calculator
watch
doesn't care. That's the beauty of it.
Wouldn't that be 100,000?
That'd be 100 million. Because it's 100,000 million.
Okay, I see now.
Good for a while.
All right, I'm ready to get an answer here.
20 years.
right, just share some answers. What'd you come up with? 20.725. But, okay, you're right on target. If you didn't get that, write that down. That's what you're shooting for. 20.725. But then, answer the question. So in 2020,
Yeah.
because it's 20.725 years after 2000. Everybody okay? Got it? All right, last one on this section. This, unlike the rest of them, is decay. This is decay. Please pay attention. All right? When we talk about half-life, that means we are going to be multiplying by a half. Does that make sense to you? So we started with 10 grams of the stuff. We would go down to 5. And then we would go down to 2.5, and so on. So we are starting with 3.5 grams of the stuff. We are talking about half-life, so 1/2, we're multiplying by 1/2. And we want to know,
For the X is X.
okay, so let me just put a T up here, or an X. Okay? Now, if I left it like that, that would mean every day, I'm cutting it in half. Now, is that what's happening? Every day I'm cutting it in half?
No.
Every 65 days. So I have to alter my exponent and make it T over 65. Now, before you get freaked out, stop. If I wait 65 days, if I put 65 in there, wouldn't that give me a 1? And I would cut it in half one time, which is exactly what's supposed to happen, right? So every 65 days means, think of it like this, per 65 days goes in the denominator. 65 goes in the denominator. There's my equation. Now, that's A. When will there be less than 1 gram? So can I graph that and graph 1 and see where they cross? Don't forget to adjust your window a lot. Wow. You need a big X.
Yeah. Big window.
The window, I had to play with it 4 or 5 times. I had to make changes. But my X's are 0 to 150, and my Y's are 0 to 2. And that gave me a picture that I can use. So I got 117.478. Anybody else get that?
Indeed.
Okay, so what's that mean? That means if I wait 117 days, I will have 1 gram left. So anything after 117 and a half, basically, I will have less than 1 gram left.
You wouldn't for now over 65.
No, that's T. That's T. So, yeah. And what that would mean, Jack, is if I take that 117 and divide it by 65, it's 1.8. So that would, yeah, yep. Okay? Alright. That takes care of you two, and now it's time for Greek living. Right. Stop. Stop. What is on the, somebody tell him what this is on Wednesday look like?
Exponent.
The practice sheet.
The practice sheet that we literally
The
just
practice
did.
sheet.
Yeah,
The one that said practice on it, okay? Oh my gosh, okay.
It's 3:05.
I think we're good.
Have a little
You are
birthday.
good.
We are so good.
Alright, number 1, 3-3, we're getting ready to learn how to handle logarithms. Alright?
Just like we got 25.
BYU, just like I
No.
Now, there are 2 ways that you can approach these problems, and the way you do it is completely up to you. One way might click with you better than another way, so I'm going to show you both ways. Sense of direction say evaluate. That means find the value of, so I'm going to set it equal to x. I'm going to figure out what is the value of that thing. Now, one way to do it is to what we call loop-de-loop. So start here with this number, 5 to the x equals 5. So in other words, none of us, including me, think in logarithms. We don't think that way. So we'll get rid of the logarithm by loop-de-looping. 5 to the x equals 5. Well, now, that makes sense to me. 5 to what power will give me 5? 1. So the answer to the problem is 1. It's another way of writing an exponential. So these 2 sentences are exactly the same. All right, now listen. There's another way to do this problem. This is called loop-de-loop. This is how we get rid, some people call it log rolling. This is how we get rid of the logarithm. There is a property with logarithms that says if your base of your logarithm and the base of the exponent, if these 2 numbers match, then the answer will always be that. So if you look at what I had originally, isn't that what I had originally? These 2 match, so the answer is 1. Anytime you can make these 2 match, the answer will be whatever that exponent is. So, if you want to do it that way for the next one, we'll do it both ways. But tell me about 16. What's 16? 4 squared? Isn't 16 4 squared?
Yeah.
So the answer to the problem is 2. Or, if you want to loop-de-loop it, you'll say 4 to the x equals 16. So what's x?
2.
Yeah, doesn't matter which way you do it, the answer's 2. You'll do it the way that you are most comfortable. Now, ln is the symbol for log base E. If you are comfortable with ln, leave it ln. But you can always rewrite it as log base E. So, problem C says log base E of e to the 10th. Wait a second, these two match. What's the answer? 10. 10. When these two match, the answer is the exponent. And ln was a log base e. The problem was e to the 10th. Those two matched, so the answer is 10. Now, because I like you so much, I'm going to give you a little secret here, and you already may know it from your teacher last year. ln, natural logarithms, and e's are inverses of each other. So anytime that an ln, an actual ln, is touching an e, they're going to cancel. Anytime that an ln touches an e, they're going to cancel. So I've given you 3 ways to do this problem. You can looky-loo it. Oh, I didn't do that.
Yeah, I think
So here's the looky-loo way. E to the x equals e to the 10th. So currently x is 10. I use my property. Log base e of e to the 10th is 10. And then I use my handy dandy marvelous shortcut. When ln and e touch each other, they cancel. Okay, that's not a log and e, that is ln. Alright, couple more and then we'll be done, but we gotta get through a couple more. Here we go. Problem D. Log base e of the cube root of e. Now let's say we're gonna log roll it. We've got 3 options. One of them is log rolling, or loopy-looing. So e to the x equals cube root of e. What power is a cube root? No, it's not.
1/3.
1/3.
1/3. 1/3. Remember, this is on your quiz. How do you get radicals? You have fractional exponents. So that would be 1/3.
Does it also work because they're the same?
Well, you gotta be careful because the original problem was written this way. The ln and the e are touching. There's something in between them. So you would have to rewrite that. That's e to the 1/3. Now this is cancel and get 1/3.
When you make it,
What?
when you square root, you go
Here,
Yeah.
looky-loo. E to the x equals that.
I was saying when you change.
Oh, I see what you did.
And that, you're gonna need that in your solid logarithmic equations, so you need to know that. You need to know how to loop-de-loop. Even though you don't necessarily have to do that every problem, you need that skill. So e to the x equals that. All right, one more. And then we'll be done. Oh, and it's a good one.
We're done?
Problem E. Nope, not a day 2 problem. What do you think? It's 10. It's 10. Guys, there's another property of logarithms that says when these 2 numbers match, right here, they cancel out, and the answer is 6. Well, here, x, the answer is x. Here it would be 10. Because the 6's cancel, so the answer's 10. Stop, do F. What's F?
Two.
Two.
That's two, yep, all right, we'll stop there. We'll stop there.
Well,
Go on. We gotta know our properties. And I'm slowly reducing them.
Joe and Buddy.